Building a model steam plant using 2 engines. This is part 3. Mounting the components on the baseboard. I'm sure that most viewers will have heard of the old saying, measure twice, cut once. Although I'm not going to be cutting anything, I'm going to be drilling some holes. The 3 major components of this steam plant, the 2 engines and the boiler plant, need to be in line, and they need to look right. I've measured the position around the edge of the baseboard of the beam engine, and now I'm drawing round it with my eyebrow pencil. Well, it's not my eyebrow pencil, you understand, it belongs to my daughter Charlotte. I'd just like to say to the viewers who kindly commented, yes, I am aware of Chinograph pencils. I used to use them every day in my recording studio for writing the track names on the mixer. These days all you have to do is type the individual names of the tracks into the computer, so a Chinograph pencil is a bit redundant. I could have typed it into Google and bought one online, but I needed the pencil fairly quickly. Why am I using an eyebrow pencil? Well, it's so that I can wipe off the marks from the baseboard. Like this. This mark is obviously in the wrong place. I got a good comment from one viewer. He said that I should use my Sharpie pen, which is a permanent marker, and then if I wanted to remove the line made by the permanent marker, I should simply draw over the line with the permanent marker again, and before the ink dries, wipe off both of the lines together. But I don't think I'll be trying that anytime soon, because often the solvent used in these marker pens attacks the varnish. Anyway, what's wrong with my eyebrow pencil idea? This is foolproof and it works. I marked out the position for the holes using a steel ruler, also known as a rule or a scale, or in my case a measuring stick. I've now returned the eyebrow pencil to my daughter Charlotte and she can carry on using it on her eyebrows. I've got all the marks that I need and I'm using my DeWalt drill to drill the holes through the baseboard. I like this drill a great deal. I've had it for quite a while. It's one of the earlier ones. It's quite heavy, but in some ways that's a good thing because it helps stabilise the machine. I also have a Makita battery-powered drill, but generally speaking I use this one because I prefer it. A health and safety warning when doing this, not particularly drilling a baseboard, but when using a powerful drill like this, particularly in the lower speeds, there's an awful lot of torque, and if the drill grabs, the sudden, forceful and rapid movement of the handle part of the drill can cause problems. I speak from experience. A few years ago I built a miniature steam locomotive called a Sweet Pea. Castings for these are exclusively sold by Blackgates Engineering, and I think I'm going to build another one. They're very, very simple to build. And why am I telling you this? No, it's not just a blatant advert for my friends at Blackgates Engineering. Well, I suppose it is a bit. But anyway, the reason I'm telling you this is that I was using this DeWalt drill on the lower speed to drill 2 holes in the top of the cab, and these 2 holes were for the safety valve extension pipes. I was sat on my stool in the workshop and the cab was between my knees on the floor. If I remember rightly, these pair of holes in the cab roof to take the extension pipes were 5/8 of an inch in diameter, and I was using a stepped hole cutter. The DeWalt was on its lowest speed and suddenly it grabbed, completely without warning, and twisted my back. I was in pain for about 2 weeks. So that's a cautionary tale. Beware of these drills when you're using the lowest speed, they're very powerful. At the moment though, the drill is on its highest speed, so it's not quite so powerful, and I'm using it to countersink the holes underneath the baseboard. I don't clean my workshop very frequently, not frequently enough anyway, but I generally keep the workbench space very clean. I'm using my workshop vacuum cleaner to make sure that there are no bits and pieces laid about on the bench. So now you might be thinking, why is he countersinking the top part of the holes? That is because I'm eventually going to use wood screws, and they can often cause a little bit of a ridge where they enter the wood on the baseboard of the engine. So making a shallow countersink on the top surface of the holes is to allow for any potential distortion around the holes of the engine baseboard as it's been screwed into place. So I don't have to use really massive long wood screws. I'm counterboring these holes, and once again I'm using my DeWalt drill, but this time on the slow speed, so please heed the warning that I've just gone on about. And also please note, it does need to be on the slow speed, because if this drill suddenly grabs into the hole at high speed, it will go straight through the hole. This is not metal, it's wood. Very, very different stuff. The drill bit that I'm currently using is a 5/16 of an inch drill bit. Now I need to put the engine in the correct position and just mark some pilot holes. And to do this, I'm using my small Minicraft drill fitted with a 1/8 of an inch diameter twist drill. This job is dangerous, but not to the operator, just to the engine if it falls on the floor. I've moved the baseboard forward so it's overhanging the bench, so I can drill 2 small pilot holes from underneath. This next part is fairly critical. I need to drill the pilot hole deep into the baseboard. I do not want the wood screws to split this baseboard. Make sure that the drill bit isn't too long and that it doesn't come through the top of the engine's baseboard. Right, that's another clean up, and now it's time to start the fitting of the engine to the baseboard, but only using the 2 pilot holes that I've just drilled. I'm confident that these screws are just the right length and are not going to come through the top surface of the engine's baseboard. Once the wood screws have been tightened and the engine is securely held by these, I can upend the baseboard and use a small Minicraft drill with the 1/8 of an inch diameter twist drill fitted to pilot the lower holes. Here's a top tip. This is a 7/64 drill bit and it's a bit too long for the chuck, so to stop the drill from ever coming through the top of the baseboard, you need to limit its depth. I just fitted some sort of a washer that I found in my bits and pieces drawer. And don't forget, it's always best to double check. Yes, that's perfect. So I can drill this 7/64 of an inch hole with confidence, knowing that it's not going to come through the top of the engine's baseboard. So using the 7/64 of an inch diameter drill with the washer fitted, I'm drilling the pilot holes to the required depth. In this clip I'm using a dry cloth. I don't want to use any solvent in case it damages the varnish, and I'm removing the mark left by the eyebrow pencil. A final test fit, and looking at the length of the screw, this will be fine. The camera angle makes it look a bit too long, but it isn't. In exactly the same way as previously described, with the main baseboard overhanging the bench, I screwed the engine baseboard into place, first using the front screws, then I upended the baseboard and screwed the other 2 screws in. So that's the Cyclops engine mounted in position. And now it's time to mount the Vulcan beam engine to the main baseboard in exactly the same way. I'm speeding this up because you really don't want to see all that all over again, and it's exactly the same. The only difference is the baseboard for the Vulcan beam engine is square and the one for the Cyclops isn't square. In this clip I'm using a small union cone to space the drill, because the baseboard on the boiler part of the plant is not as thick as the baseboards for the engines. So with this small union cone in position, it's impossible to drill all the way through the boiler's baseboard. Here's a semi-aerial view of the finished installation. As you can see, everything matches quite well, and the gap in between the boiler part of the plant and the Vulcan beam engine is fine for running the steam pipe. Before I could do this, I had to mount the engines to find the optimum position for the steam turret. First of all, I drill down through the baseboard, then I lift the baseboard up, and believe me, it's getting quite heavy now. Using the DeWalt drill on the slow speed, I counterbore the hole. You can see the logic in the position of the turret now. I can get to it with my large hands very easily without getting in the way of any flywheels or moving parts, and it's very easy to fill and drain the displacement lubricators. Time now to mount the chuff pot and the water tank. These are very nicely made items. I put them in the position that I want them, and in this case I spotted through with a felt tip pen because I didn't want the spot to move. And then using my small Minicraft drill, I drilled some holes into the baseboard which are tapping size for a 5BA thread. It's a good idea when doing this only to tap the hole about half of the thread length of the bolt that's going to go in there, so the bolt effectively cuts its own thread from about halfway down, and you get a nice tight fit in the wood. Or you can tap all the way down and then use some very thin CA glue or super glue to harden the thread in the wood. And here's the progress so far. Everything's mounted to the baseboard. So now the fun begins, or for me the easy part, piping it all together. I can't say I'm looking forward to wrapping the live steam feed pipes in string and painting them, but it's a fairly essential thing to do because live steam is very hot. This is going to be a beautiful steam plant when it's finished. But that's it for now. Thanks for watching, and I hope you found it useful.